Looking at solving inequalities, if you did not read the team's message, you are not required to attempt 1, 2, 3, or 4, or 5. In this video, I'm going to complete 6 through 9 with you. Recall that after you solve the inequality, you do need to graph the solution set on a number line. Let's start with number 6. So the first thing I'm going to do is, before I can graph the solution set, I need to figure out where are these hash marks. So I'm going to set the left side equal to 0, and I'm going to solve. Now, how will I solve? I'm going to try factoring. If it doesn't work, I'll use the quadratic formula. That's my next move. What multiplies equal negative 12 and combines to equal negative 11? Different signs, with the larger number being negative. Negative 12, positive 3. So I have x minus 12, x plus 1 equals 0. Now remember, when the leading coefficient using this method is anything other than positive 1, I do need to put it down below. And then I simplify. I can't simplify 1/3, leaves it as is. I believe one hash mark is at 4. I believe the other is at negative 1. Okay, so now we are going to write these in order. So negative comes before positive. I'm going to come up here with a negative 1/3 and a positive 4. This tells me I'm going to do a closed dot, means it's part of the solution set. And now where does 0 land? Well, because it's not a hash mark, I'm lucky. It's going to be in between here. I'm going to test this. So I'm going to plug 0 into the left-hand side at this moment. So 3 times 0 squared. You're welcome to do this in your mind if that's a possibility for you. So when I plug in 0, I get negative 4. And I want to answer this question. I got negative 4 on the left. Is negative 4, in fact, less than or equal to 0? So is this math statement true? It is true. So this is a yes, and it alternates. So no, yes, no. But wherever there's a yes, you must go back and shade. That's question number 6. Let's look now at question number 7. So question number 7, just like number 6, is I need to know where are these hash marks on the number line. Now, how do I know when you're going to have to shade? Whenever you have an inequality, we're going to use shading in order to represent the solution set on a real number line. Okay, so I'm going to do factoring because I have 4 different terms here. I'm going to do factoring by grouping. I'm going to set this equal to 0 and then factoring by grouping in order to solve to find those values for the hash marks. I can factor out an x squared. I'd be left with x plus 6. What value times 4 is negative 4x, and that works. Negative 4x minus 24. Both the front and the back have an x plus 4. In front would be an x squared minus 4. I'm going to set each of these groups equal to 0 to solve. So x plus 4 equals 0 and x squared minus 4 equals 0. So I believe one hash mark is negative 6. I believe the other hash mark, gives me 2 answers, would be plus or minus 2. Okay, I'm going to write them in order now from least to greatest. Negative 6, negative 2, and positive 2. Negative 6, negative 2, and positive 2. Notice that the inequality symbol does not have a line underneath, so I have open circles at these places. And then I always choose to use 0 as my testing point, as long as it's not a hash mark. So here's where 0 lands. This is going to be my testing. So I'm now going to plug in 0 on the left-hand side. Here we go. Plugging in 0. I have, and you can do this in your mind if that works for you. So I've substituted 0 on the left-hand side, and I achieve an answer of negative 24. So negative 24 is less than 0. Is that a true statement? It is a true statement. The mouth of the alligator is eating the larger number, so this would be a yes, and then it alternates. Wherever you have a yes, you must shade. Remember, I'm shading the solutions that would make this math statement true. Okay, let's look at this question. Just like 6 and 7, I'm going to try to find those hash marks. So I'm going to have at most 3, and I'm going to now factor out an x to be left with 1x squared plus 6x plus 9. I'm going to set it equal to 0 in order to find where the hash marks land. Okay, this is factorable. What multiplies to equal 9 and combines to give you 6? That'd be 3 and 3. X plus 3 and x plus 3. Don't forget about the x out front. And whenever this is any value, the leading coefficient is any value other than a positive 1, you must put it underneath the values and then simplify. Doing 1 is not going to make a difference. So I'm going to set each one of these quantities equal to 0, and I'm going to solve. And I end up with answers of 0, of negative 3, and negative 3. Now, how does this different than number 6 and Number 7, I have a duplicate answer. So I'm going to put them in order, and I can see I need to do a closed dot at both -3 and 0. Now here's what happens. At the duplicate part, I know on both sides it's going to be the same. On both sides it's going to be the same. So it's going to be like yes, yes, and then alternates no, or no, no, and then alternates yes. Now this time I also can't use 0. Why? Because it's already a hash mark. So I choose any other arbitrary number. Like I'm going to choose to do, it doesn't matter, I'm going to choose to do 1. So if this is a yes, I'm just predicting, if this is a yes, then it's going to go no, no, because these have to be the same on either side of the duplicate answer. Or if this is a no, then it's yes, yes. Okay, let's try 1. So I'm going to plug 1 up into this particular problem. So I have 1 cubed plus 6 times 1. Many of you could do this in your head. Plus 9 times 1, and I get an answer of 16. So is 16 less than or equal to 0? This was 16. No, that's not a true statement. So I tested 1, which is over here. This is my testing, and it was a no. And so then it's yes, yes. Because it has to alternate, but these also have to be exactly the same on opposite side. Wherever it's a yes, I'm going to go ahead and I'm going to shade that. Okay, let's go ahead and let's look at number 9. You may be thinking, is 8 exactly the same as 9? Well, they're very similar. They're very similar, except for the inequality symbol. That's the only difference. So just like I did the previous one, I can kind of copy off of how I originally set it up to solve. So I'm going to write this down at this time. X plus 3, and x plus 3. Again, I'm setting it equal to 0 to find those hash marks. And I already showed you how this was 0, -3, and -3. So writing this in order, I come up to -3 and 0. But this time I have going to have closed dots. I have closed dots. Oh, sorry. This time I wrote it down wrong. This should have just been a less than. This time I'm going to have open circles. So open circles here. But I have a duplicate, so this is going to be the exact same on both sides. Again, I can't test 0. I'm going to go ahead and test 1. Let's go ahead and test 1 to see what we have. So I'm going to plug it back in, and the same is going to be true. I'm still going to get, like in the last, in problem number 8, I achieved 16 when I plugged this in. So it's going to say 16 is less than 0 instead of less than or equal. Is this true? It's not true. So this is a no, and these have to be the same. So the only difference between number 8 and number 9 is they look exactly the same, except for I have open circles on 9, and on 8 I have closed. Now I'm going to give you one more sneak peek. So if you've been with me here, hopefully this will help you for your upcoming test. Hint, hint. I'm going to add 2 extra problems, and if you're watching this, I think you'll be better prepared for your Unit 2 test. What do I do here? Well, I can factor out x and be left with x minus 9. So I'm going to set each of these equal to 0, and I'm going to solve to find those hash marks. So x equals 0, and x equals 9. Okay, those are my hash marks. So I'm going to go and put them in order, 0 and then 9. I have open circles. Oh, I can't plug in 0 because it's a hash mark. So plug in any other number. I'm going to test 1. So this is going to be my test area. 1 squared is 1. 9 times 1 is 9. There's a subtraction in between. 1 minus 9 is -8. Is this a true statement? Is -8 less than 0? It is. I tested this area. It's true, and it has to alternate. So yes, no, yes. Let's come over here, and I'm going to do the exact same thing. I'm going to pull out an x and be left with x minus 16. Okay, set each of these equal to 0 and solve. So I have 16 and 0. Putting them in order. This time I have a closed circle. And again, I can't test 0 because it's a hash mark. So I'll choose any other number, like 1. 1 squared is 1. 16 times 1 is 16 with a subtraction. 1 minus 16 is -15. Is -15 greater than or equal to 0? No, that's not true. So this is a no, and it's going to alternate. I only shade where it's a yes.